Hello everyone, in this video I'm going to explain integration by using tables. If you recall, we have discussed many methods for integration like basic logarithmic form, inverse trigonometric form, power of a function, and as well as integration by parts, integration by partial fractions, etc. So using all those methods and some more, mathematicians have formed a table of formulas for integration, which makes the process really easy because we have to use many steps while using one of the methods that we have discussed earlier. But if you can recognize the form of an integral, then it's easier to just find the integral from the table. So I'll show you the table soon. So if you look at the table, so you will notice that you see there's some letters like U. So U we use as the integration variable, and the other letters like A, B, M, and N. So those are various constants in the formulas. Show you what the formula sheet looks like that we are going to use in our examples. So you can see that here we have different integrals, and u is the variable, integration variable, and rest we have c, which is a constant, and then we have some a's, and we have powers like m, and we have some A's and B's in the formula. So all these are our constant. So we have different forms involving different algebraic expressions, and this is a big list of the formula which has more than 100 formulas here. So we're going to use these formulas in order to solve some integral problems today. So let's take a look at this example. Integral of 1 over x squared minus 25 dx. And let's say I give you this formula that integral of 1 over u square minus a square du equals to 1 over 2a ln of mod of u minus a over u plus a plus c. So if I give you this formula, so you can recognize the form that the given integral is of the form 1 over x square minus some constant square, which is applicable to this form. So we can just in one step write our final solution. So using this formula for u equal to x and a equals to 5, we get integral of 1 over x squared minus 25 dx equals to, so 1 over 2a, it means 1 over 2 times 5 ln of u minus a over u plus a, so put x at 5 there, plus c. So overall we get 1 over 10 ln x minus 5 over x plus 5 plus c. So that is our solution in just one step, just by using the formula, just by looking at the table. Now think about, what if we don't have the formula? What would you have done in that case in order to find this integral? So what are you thinking? Integration by partial fractions? Yes, you should try that. All right, so let's take a look at a few more examples, and we're going to use the table for that to solve the examples. So here we have calculate integral of x square root of 7 plus 6x dx. And we haven't learned any method that can help us to solve this integral. So let's just take a look at table. So if I take a look at the table, I notice that this integral is of the form formula number 100. So integral of u square root of a plus b u du. So it's given by this formula. So we're going to use this formula to solve our integral. So we're going to use formula number 100 here. So we are going to use formula number 100 with u equal to x a equals 2. So if you compare, a is equal to 7 and b is equal to 6. So using u equal to x, a equals to 7 and b equal to 6, in this formula we get, so this integral is equal to 2 over 15 b square. So 2 over 15 times b square means 6 square. 3 times b, so b is 6. In place of u, we have x. The variable of integration is x. Minus 2 times 7. And we have a plus bu. So a is 7 plus 6x. 3 over 2 plus c. So when we solve this and simplify it, so 2 gonna get cancelled. So we get 1 over 270. 18x minus 14. 7 plus 6x raised to power 3 by 2 plus c. So that's how we use the table of integration, the formulas from the table to solve our integrals. In this next example, we have integral of square root of 4 minus 9x squared divided by x dx. So first thing we notice that, so this integral is having a factor of the form square root of 2 square minus 3x whole square divided by x dx. And we're going to look for the corresponding formula in the table. So let's take a look. So this one looks of the form a square minus u square. So you have like constant square minus a variable square. So that is under the square root. So that kind of factor you have in the formula. So it's very important that you recognize the form. And then we look in the table and we try to recognize this type of form in the table. So we notice that, so a square minus u square over the variable u du. So this is the similar form that we can use in our formula. So we need to use this formula in order to solve the integral in question. Using formula number 69 with a equals to 2 and u equals to 3x, we get, so the given integral, I'm just going to rewrite this in the form 2 square minus 3x square over x dx. And I noticed that, so here we have u square and we have u in the bottom as well. And we have du. So in this case, I have 3x here. So I need a 3x in the bottom. So we add another 3 so that we have the same u here. So if I am dividing by 3, I have to multiply by 3. So now we have the required form and we can write our answer. So it means our answer should be square root of a square minus u square. So 4 minus 9x squared minus a, which is 2, ln a plus a square minus u square divided by u, which is 3x plus c. All right, let's try an definite integral using the table of formulas. So in this one, we notice that we have integral of 5x plus 7 times sine x dx. If I scroll through my list of the formulas, I don't see anything that involves that form. So maybe I need to do some algebraic manipulation before I can actually look for the formulas. So we have no direct formula, but I can rewrite this as sum of two integrals. So 5x sine x dx plus integral 2.5 to 7 and then 7 sine x dx. And now I will again look in my list and then I can notice that I have a formula for this integral. So x times sine x dx. So we have this formula number 53, which gives us the integral of product of u and sine u. And we can just use this formula. Using u equal to x, we get, thus using this formula with u equal to x, we get So 5 is a constant. So integral of x sine x would be sine x minus x cosine x, and the integration limits are from 2.5 to 7 and plus 7, and integral of sine is negative cosine. So I'm just gonna put negative here. So cosine x from 2.5 to 7. And let's just put the lower limit minus upper limit. So we get, so first we put 7 in place of x, and then minus sine of 2.5 minus 2.5 cosine of 2.5. Okay, and in the end we get negative 7 cos 7 minus cos 2.5. When we solve this, in the end we get negative 46.99 as our value of this definite integral. Let's try this problem. We have done this earlier using one of the trigonometric forms, but now we're just going to use the table formula from the table and see how we can do this using the formula. So we have integral of sine raised to some power cosine raised to some power dx. So if we look in the formula sheet, we see that we have something of the same form here. So we're going to use this formula. So there are two formulas for this form, so we'll use one of them to write our solution. So we are using this formula with, so n equals to 3 and m equals to 4 and u equals to x. And we get sine integral of sine cube x cosine raised to power 4x dx is equal to negative sine. So n is 3, so 3 minus 1 x cosine 4 plus 1 x over 3 plus 4 plus, so n is 3, 3 minus 1 over 3 plus 4, integral of sine, so 3 minus 2x, and cosine 4x dx. So we get negative sine square x cosine raised to power 5x over 7 and plus 2 over 7 integral of, so cosine 4x, and then we have sine 1 power of sine x dx. For this integral, we notice that this can be in the power function form, or you can again use the table method, or you can use one of the non-trigonometric methods. So fx raised to power n. So if you have the differential of fx along with, so you can use the power function. So in this case, the derivative of cosine is negative sine, so we need to add a negative here, and for that let's add another negative here so that we can balance our negative. Thus we get, so integral of this would be cosine raised to power 5x over 5 plus c. And in the next step, 7 times 5 is 35 in the denominator. And this is our overall solution to the given problem. I hope that makes sense. So while using the method of integration by the use of tables, it's very important to recognize the form of the integral first, and then you can choose the required formula. If you like this video, please hit the like button and also subscribe to my channel. See you next time. Bye for now.